record right now. Okay, here we go. Sorry, folks, we're going to do a little bit of introduction again. My name is Michele Cosi, and I am the presenter for Functional Open Science Skills for AI and ML applications. And today's discussion will be AI's role and tools in open science. Now, as AI becomes available to the public in a larger form, it is important to also discuss how this is impacting the field of open science. Just because it is available out there, it does not necessarily mean that you should jump on it with your eyes closed without really understanding what is going on. And for today, I wanted to bring in a couple of my colleagues, which are experts in the field. And we have Carlos Lizarraga, which is here with me. He is a connoisseur of anything that is classical machine learning to AI. And we also have Dr. Enrique Noriega online, which is also an expert in the field of AI. Both of them have their own data lab related workshops. One of them is classical machine learning, which happens from 1 to 2 on the Tuesdays. And the other one is Gen AI, which happens between 1 to 2 on the Thursdays. Together, they run something called excuse me, I'm gonna admit this person. They run together something called the AI Makerspace at Snakes and Lattes on Tuesdays from 3:30 to 4:30, where you can bring your questions, your topics, your own work, and discuss how AI can be implemented in it, or answer questions that you may have about a specific tool or a specific workflow. This is going to be the second week of our FOSS and AI workshop series. Excuse me, I'm jumping around. Here we go. And with this, please, if you do want to follow along, we don't really need this, but this is where all of our material for FOSS AI lives. So please feel free to bookmark this or have it somewhere. And you can click on the material button right here to get into today's discussion. We're going to cover roughly 3 questions, and by all means, if you have your own opinions about this today, I welcome them. Today is not going to take the entire hour. I'm aiming to roughly 30 to maybe 45 minutes, depending if there is a discussion that's coming out of it. And I wanted to start with a sentence or a quote coming from UNESCO. UNESCO held a discussion, let's call it, in June 2024, which covered exactly this topic. This event was named Exploring Opportunities and Challenges at the Intersection of Open Science and Artificial Intelligence. And it was a couple of hours long, covering the topics that we're covering today. And I wanted to take this blurb out, which is actually quite interesting. While AI represents rapid scientific advances, its integration must align with open science principles to ensure replicability, credibility, equity, and trustworthiness. Now, let's remember some of the discussions that we have had last week. Open science is not necessarily a strict method, yet it is a set of pillars, a set of behaviors that you should learn when you're doing your own science. You should try to apply, you should try to make your science open rather than, oh, you should follow this protocol, even though we have seen last week there is a not so strict framework to do open science. Continuing the quote, open science offers mutual benefits for AI by expanding participation in research and promoting inclusive practices. The open science approach, when combining with AI technologies, can significantly contribute to addressing the current pressing global threats. Now, this is roughly 4 lines of big words and jargon that don't really address what AI's role in open science is, but it gives us a lot to think about. And today we're going to try to tackle 3 questions. And the first one will be the role of AI in automated research and discovery. The second is AI's impact on research accessibility and collaboration. And the third is the ethics of AI-generated scientific knowledge. So without further ado, I'd like to open the floor to everybody that is currently online or in person. And I would like to also ask Enrique and Carlos to give their opinions about what they know of the role of AI in open science. So here goes the first question. Carlos, Enrique, thank you for being here. How would you say, perhaps in a more general way, what is, from what you think, the role of AI in automated research and discovery? What's happening today, and what is going to happen going forward that you can foresee?
Enrique, you want to go first, or should I go?
However you want. Maybe I can take a first step.
Yeah, go right ahead.
Sure. So I think this is a very interesting question. Mostly because nowadays every science that we explore is digital in a sense. So all of our artifacts or the traces of our lives and all the information that we generate is digitalized basically right out of the gate, right? So we use computers, we use personal devices, our even as we can see on the graphic, our DNA is being sequenced, and we have a digital version of our own code. And vast amount of data that we have is basically impossible to figure out by hand, right? So we need to make use of computational tools, and the perfect match to deal with these tropes of data is using AI and machine learning methods, basically to parse them and to make sense out of it. So that would be my fundamental observation. So this is the tool that we, or the family of tools that we rely in general to implement any type of algorithmic reasoning out of data that comes out of nature. So, and when I say nature, it could be your gene sequencing, or it could be our speech that we're speaking, or something that goes out on the internet like text, images, and whatnot.
That's a good point. Yes, everything that we do effective nowadays is essentially digitalized, and it can become part of a larger workflow. Generally speaking, I took this graphic from a 2024 paper, I believe. Yes, it is. The role of artificial intelligence in revolutionizing drug discovery. And I think it goes quite hand in hand with what you were saying. Everything is digital, and everything that is digital can become, after all, part of a workflow. I am going to share this paper, which I thought was quite interesting, with everyone, simply because it is right on the topic. But do you have anything to add on that?
Well, I agree in part with what Enrique is saying and you, Michele. But I know that there is a large discussion right now about LLMs and science, because some people may have the impression that large language models can be a tool to do science, but it's basically not exactly a tool, because large language models are just a creation of reading texts and trying to compute probabilities of what is the next word when you're talking into a phrase. So you have to think more of a collaborator, for example, as any PI or any researcher has like grad students or assistants, right? So large language model probably can facilitate writings, codings, or knowledge extraction. But can you, if you base a research using LLMs, can it be reproducible? Probably not. Also, there are several tasks we do. We give to the large language models like paper reviewing, extracting abstracts, or synthesizing documents. But sometimes if we ask a large language model some questions, it may hallucinate and even invent references or design some papers to real authors, and the author never wrote something about that. And another thing is that science making science. I know that science is something that we have used across our history of humankind, trying to understand natural phenomena. But can AI discover or decide by itself what needs to be researched or what problem is more relevant? That is more like a social aspect of science. The scientific community decides what to do research on, when, and what is needed. And AI cannot decide by itself what is relevant for us or for science in any moment. So science is a social process that cannot be auto-completed by AI.
So if I'm understanding what both of you and Enrique are saying is this is a fantastic set of tools that we are receiving or that we have available right now, but we may fall into the trap of allowing it to hallucinate and make science that doesn't yet exist. And I think that's an important statement where for anything, you can access a specific tool, you can access a specific algorithm, but there is always a little bit of drawbacks that we might fall into or that we might run into. A couple of secondary questions on this. The first is within the realm of AI and open science, so the science that's accessible to everyone, what are some of the tools related to specifically what we're seeing right here? So automated research, perhaps not necessarily drug discovery, but how I see a lot of tools such as DeepSeek. I see a lot of tools such as the ones given by OpenAI and Olama, but how do you implement those into research? That's my first question. And the second is, what are some of the future fallacies that we might fall in if we stick with this set of tools that we have today? So let's start with the first question. What are some of the tools that you know are useful in these in the world of open science?
Well, let me just capitulate a little bit on what Carlos mentioned. I think that and that will be a segue into answering the question.
Sure.
My answer to the question. I could think about using AI for research nowadays, like having an exoskeleton that allows you to walk faster and be stronger at doing your physical tasks, but in the intellectual domain. So we are constrained by our cognitive bandwidth, if I may say so. That we don't like we need to sleep 8 hours a day. We have to pay attention only at one thing, perhaps two if you're good multitasking. But we cannot do much more. And even if we are in a multi-member team, we're bounded by the human capability. That's where the AI shines to sort and dice through large troves of data if we tell it how to do it. And previously, these skills were available to people, but you had to know like programming languages. You had to know statistics, and you need to have some specialized knowledge and access to hardware resources. Nowadays, like this might be assumed for scientists like computer scientists or engineers, but if you're a social scientist and you specialize in doing qualitative research, you might not have some prior experience on learning how to code, or perhaps mostly basic. But then by using an LLM, you can command it to speed up the code or to actually reason, quote unquote, about something that you're looking at and do it at large scale. But then we fall into those limitations, the hallucinations and all those drawbacks. So that being said, so I think that sets the stage. Like, what tools can we use, and what are the current shortfalls, and what are we doing about it to mitigate those? So some of the tools, first of all, LLMs, right? That's like the new favorite kid on the block. So you could use OpenAI or ChatGPT. You could use Google Gemini. You can run them on your own computer, or if you're in the university here, you can use AI Birdie. So we already provide some graphical user interfaces such that you can speak with an LLM and chat about in a free form. So basically, instead of commanding a computer by writing code, you command a computer speaking to it. And it doesn't have to be English. It could be any other language that the LLM has been trained on. And this basically means virtually any widely spoken language. So here's the first drawback. There's going to be some accessibility issues to people who want to speak on, say, a Native American language, or a language that it's not properly served, if I may say so, by the mainstream commercial providers. So that is one tool. So we have multiple software packages to run those LLMs. We have multiple user interfaces. So there's LM Studio, there's the Hugging Face dashboard, there's the ChatGPT app, so forth. And if you want to dip your toes deeper into the technical side, there has been a lot of open source projects that allow you to develop your own LM-based applications. Like we have LangChain, we have Llama Index, we have the Hugging Face ecosystem that allows you to mix and match multiple types of language models or any other machine learning models to build an AI-powered application. So this becomes like a loop. Like you still need to know how to code if you want to achieve something very specific, but you can get aid by the language models themselves. And when I also say a language model, it doesn't necessarily, well, the name says language, but nowadays these are multimodal models, meaning that you can speak to them, you can show pictures to them, or you can use any combination of those. So you can present a picture and ask questions about it, or you can ask for a picture using a prompt. You can get a rendered image as a result.
Right. I would like to remind folks that sure, we have AI available to everyone nowadays, but it doesn't necessarily mean that the AI will do the work for you. One thing that Enrique did point out is that the AI can point you towards the answer. You can use AI to help you find the answer, but the AI is not going to give you the answer. You still have to understand what code the AI is generating, you don't just blindly close your eyes and believe everything that the AI is saying. So with that in mind, is there anything you want to add to that, Enrique?
Yeah, so what the point that you're raising, it's an excellent point. LLMs are limited. So we're making progress every single day, and you'll see some amazing stuff out on the internet every once in a while. But in the end, this type of models rely, as Carlos just said, they're predicting what is the next word based on the prior history. So initially, they were glorified autocompletes, but with clever research and tricks, I know this is an oversimplification, but we've made them such that they exhibit capabilities that resemble something like reasoning, like explaining themselves, like you are asking something and they're going to give you an answer, but instead of just spitting out the answer, they might list what are the steps, the chain of thought that led them to elicit that answer. So even though this appears like they're reasoning, it still relies on the trained data. So these models were trained to resemble the thought process of a person. And this was basically put together by thousands of people writing this together and using some reinforcement learning tricks such that we achieve this result. And again, like there are multiple specializations. Like we may have an LLM that is great at coding because we've showed it a lot of source code, basically all of GitHub or all the open source repositories that are out online. And then people start describing, this block of code does this. So when you ask for something, it already has seen some code that does something similar. And by the generalization capabilities of deep neural networks, they can extrapolate. If you ask an LLM to code you something very specific, as long as it has seen all the components, even if they were separated somewhere else, it can put together the solution that takes you out 80% out of the way into doing what you want to do. But there might be mistakes, like they're not a compiler. They don't have access to your state of mind, like they cannot read your mind. You still need to verify it because it's going to hallucinate something. So the side effect of this is that they're going to say whatever that looks correctly. So, but that doesn't mean that it's correct because it might be grammatically correct, but it might not. It might be fallacious, like it might be spurious in a sense. So you need to know about what you're expecting,
Right.
and if you see something that risks of being a hallucination, you need to be able to verify.
Right. Statistically, it may look correct. Grammatically, maybe it is correct, but maybe the words don't make sense. Maybe the sentence does not make sense. And
even if it makes sense, it might be factually incorrect.
right, that's true. That's absolutely true. Okay, with that, and in the interest of time, I would like to move on to the next discussion topic, which is AI impacts on research accessibility and collaboration. And maybe this is a little bit general as a topic, but I did want to still know what you guys think about this. How do you see AI impacting current publications or collaborations? And I've added, I think this and the next questions sort of go hand in hand, which is the ethics of scientific knowledge. We touched already on it a little bit right now with Enrique mentioning, well, we just feed the entirety of GitHub, and eventually you'll figure out, the AI is going to figure out whatever the code is doing. But the point that I want to get to is open science is working with me, myself, my coworker Carlos, someone that is across the sea on a different time zone. And the internet allows us to do this, and open science is allowing us to share things that we are learning at a lot quicker way. Do you see AI as speeding this this current how this works, or do you see AI being more of a problem of how this works? And let me give you an example. A lot of the people, I fall in this category, a lot of people may not know a lot about a specific topic, so they rely on AI to catch up on a field. However, AI may be wrong. So read your papers, make sure that you actually do read your papers. Don't generally rely on AI to just create a summary. Use AI to help you understand a specific topic. But how do you see accessibility and collaborations being impacted by AI? And this goes, anyone can answer.
Well, we go again back to what AI can do and what it can't. For example, if I'm trying to do some information extraction using natural language processing, you have to design and know what type of information you're trying to extract, and then give the tasks to some AI assisted system. You can be successful in that task. Another type of task we can do, for example, have the AI redact a letter, an invitation, something that for us takes more minutes than AIs. Then once we have the output from the AI, we still have to review it and see if it makes sense. Because large language models, for example, are not information generating systems. We have to see if they have sense. Another thing we can do is ask AI to draft some text, draft some transcriptions, or do a machine translation, do code generation, but we cannot rely them on giving us new ideas because maybe the information is not reliable.
So once again, it goes, sorry, go ahead.
Some tasks can be done by AI or can help us do our daily tasks, but there are some others that still rely on humans.
Okay. You know, not to minimize the effect that AI is having on the research itself, but a lot of the tasks that AI can do is simplifying your day in a sense. So help me draft the email, help me, maybe I'm extending here, but help me create a summary of these notes, not necessarily used to create the science. And this is a point that we were discussing earlier. AI is not going to make the science. AI is going to help us infer what the science is. Enrique, do you want to add something to that, or?
Yeah, I think that's a great point. So the AI is, or generative AI or LLMs are just repeating whatever they saw during train data in the same form that they saw it during the train data. So as Carlos was saying, we cannot rely on them giving us research ideas. Perhaps by chance they'll spit out something that's good, but you cannot assume that's gonna hold over. Some other issue that I see is that one principle of good science is reproducibility, and LMs are hard to wrangle in this dimension, because by the nature of the generative components, there's going to be some beam search, or there's going to be some non-deterministic component there that usually you can turn off, but if you do that, I see like if it was a Schrodinger's cat, like you could have multiple answers to a prompt, but just
Mhm.
realize one. But every time, like if there are multiple parameters in which you can um, control that stochastic process, but if you're not careful enough, every time that you ask for a summary or you ask it to generate an answer or a hypothesis, it's going to give you a different one. So you need to be really careful about setting the temperature to 0, setting all the penalization parameters to the same value every time that you call it. If you want to um, stand by those principles of reproducibility for good science. Something though that I think I am hopeful is that even though we cannot rely on just the outputs of a language model for hypothesis discovery or as a peer in scientific development, uh, there's a lot of work on agent systems in which you use the LMs instead of as generators of ideas, you use them as orchestrators of different
Mm.
steps that you could use to automatically help you find relevant information that will drive your own conclusions about it. So that is another angle that I think that it's still nascent, but in the coming months or years is going to be extremely popular for science and for the industry at large too.
It's actually quite something that I'm learning myself as well. Do you have an example of what you're just talking about? That's straight off of your head, or
Yes, so something that we've been working on. Say that you have database like you're a researcher on the plant sciences domain, and you want some data, and you got a SQL database, but you know SQL, and maybe you know the basics, but you know how to do like um, an inner join and then a union of multiple tables, and and the data that you need is a result of doing such operation. Um, with an LM, an agent version or an agent system that uses LMs under the hood, the LM can elicit the code and you can drive it such that you get the actual query that you need and you get the data in the shape that you want to do. We've done this some experiments and it looks very promising. Also, I think that today or yesterday, OpenAI released their Deep Researcher that it's somehow embodies this type of philosophy. And there are some other experiments like using LangChain or Hugging Face. You can use research assistants to bring forward the information that might be relevant to you.
yeah, that's pretty cool. I do see a hand up from Miki. Please go right ahead. You can unmute and chat.
Yeah. I have a question. Like, how I see AI is basically it is the next generation of the data storage that we used to have, something which started from a flat file to the RDBMSs that we had, and now we have a AI storage, which eventually allowed us to store the relationships in a very new manner and eventually helped us figure out a similar kind of a pattern between the relationship and eventually helped us reach a stage where we can predict and go ahead and make forecasts. Uh, do you see any kind of usage or what kind of a technology probably you are aware of where we can figure out patterns between absolutely very far away or distant piece of informations? I mean, what I have seen is normally we have been working on information sets which are very close by, near adjacent. But see how human beings think is basically something that we have learned in past in one piece, one place of uh, work, and probably we use those kind of things and relate into a very different scenarios. So have you seen any such usages? This is what my quest is. If we are able to understand the relationships between the data at that level, probably the generative or the ideation part from the AI may come into picture and may come into use. That's how I am thinking, but I haven't seen any such use. So my quest is, have you guys come across any such thing?
So I've seen on the same note, using agent-based AI systems there are a lot of demos out there that showcase that they can answer questions that rely on background knowledge that it might not be readily available unless you go out and search for it. And by this, I mean, like, if you want to know who was the president of the United States during the Second World War, you need to figure out first, like, okay, I need a list of which are the presidents of the United States. Then I need a timeline, like, when was the Second World War, and then you need to narrow, like, do some logical steps to narrow down and filter that. So it requires multiple steps that you might not have explicitly written down in a document as
Okay.
a single statement, such that the LLM can give you a straight out answer. But by figuring out or decomposing the problem from a higher level question into the individual pieces that can be tackled individually each, and then composed together to give you an answer. There's a lot of that or examples like that out there. However, I have not seen some specific breakthrough or flagship product that goes beyond like, this is a toy problem. So
do I understand agentic flows which we have right now, or the technology which is in picture right now, which is available? Do you see things like these being used there, or?
yes, absolutely. And I think we're going to see it pretty soon.
Okay.
Yeah, and I was reading some article very briefly saying, for example, we know that we think our thinking process is affected by our native language. So if I was born in a different part of the world, my language will be distant and my way of thinking will be distant. So when you have large language models and you're using different data sets to train it, then probably the large language model will be, some claim that some models were thinking in Chinese and then answering in English. So the thought process is connected or influenced by the language or the documents we read. So the thinking process is not unique. It depends on your language.
That's pretty cool.
But
Make a joke. You can go ahead and create your own LLM and sell it and make millions off of it.
But one thing I want to say on this one is, see, as soon as the data is converted into digital form, my view is that that's what makes it agnostic to the language, because then the process is structured how the digital piece of information behaves, the behavior of information, what comes or what is inherited from the number systems is what comes into picture, and that probably makes it agnostic to the culture, agnostic to the way of thinking of a certain area, agnostic to the way that information of local areas behave. Because what I have in my observation, the information is a very dramatic thing. I mean, it will have some local behaviors, it will have some far-reaching behaviors, it will have behaviors within the number set, within the languages. There is a multiple set of behavior when it comes to different reach of the language itself, or the information itself. So which is what, if you see this into something like large softwares, it is very much evident, which basically will allow you to understand if you're dealing the data relative to certain numbers, certain demographics, or maybe the languages, the word itself, letters, the documents. If you see this into larger documents, you get to understand how the information behaves on different set of data itself. And that's what at least allows me to understand if you, I mean, what I mature to is that information, when it is in a certain language, if we are thinking that it is our perception probably that we are thinking in a language, but eventually it is agnostic to probably everything. It has a behavior in its own for every different set of domain, every set of data itself.
I have a hot take on this, and I'm not the expert in the field, so I can definitely be shut down. But you're not wrong when it comes down to data is digitalized and is then used to infer something. My understanding of it is, however, when you take into consideration, we're talking about SQL right now or SQL, or let's take into consideration the grammar of Chinese versus the grammar of Hindi versus the grammar of Italian, we do have different human-made set rules. And regardless whether you're speaking SQL or any other human language, you have to adhere to the rules that were created by humans and not the natural rules that are created by mathematics in this specific case. So whilst I do agree that things become data and you can manipulate data and work with data, I do also think that there are some rule sets that AI and other models have to adhere in order to work the way that we have designed for them to work. Does that make sense, Mickey?
Yes, of course. See, I'm working on a topic called behavior of information for quite past some time, and
Okay.
I'll definitely share this in the next meeting that we are going to meet in person in the AI Makers Meet. So this is a
Sure.
very interesting subject which I came across when I was designing code generators. And so I have been into software engineering for almost more than 28 years now. And I've been designing some very large, small, different sizes of software systems for different domains. And what I came across was that not only the data that we have, it has certain patterns, but the code also has a pattern. And when the code meets the data for a different domain, different variation of the piece of information, there is a different unique behavior that comes out. That intrigued me to understand basically what exactly is information. And I went outside the information domain, which is something like software. Software, I understand, is a purest form of information where there is nothing else, no physics, no nothing else. But when I took this outside the purest realm of information, it was still persisting, and there were certain new discoveries which I made. So which I was trying to validate by talking and by trying to find out different piece of information through literature, through videos. And there were some remarkable discoveries. So when you say once the data is digitized, there is a certain behavior which we are not only inheriting from the data, but also from the number patterns itself. So you understand if you are digitizing the information into certain numeric patterns. So the beautiful part about this is not only the data has a behavior, the number pattern also has its behavior, which is adding to it. So if you see the very problem of hallucination, it is being inherited not from the data, but from the number patterns itself. So this hallucination problem is from the number pattern, not from the data itself, because data, what we are getting is definitive in its own sense. Whatever we are giving is definite. But the hallucination is coming because we are using certain number systems in order to compute those piece of information, figure out something new about it, and try to figure out the patterns about it. So this is a very remarkable, very unique discovery that I came across, so I was aware about hallucination or this kind of a problem before I actually started learning machine learning, because I was thinking on the very behavior of information itself. So which is what got validated when I started getting inside how exactly are we using the gradients, the other validation techniques. So which is what came into a validation, surprisingly, that yes, there is something which will come from the number systems also. And I had a discussion with the professors, with whom I were discussing and trying to figure out why these issues are there. So there are other new, honestly speaking, my view is that machine learning and AI will eventually lead us to generate new kind of maths, to be honest. So math that we have
This
is
is very philosophical. And it's not
science.
a bad
This is
thing.
science.
Exactly, it's not a bad thing because you're following the you're following the numbers, you're following the trail, you know, this after so many years in your own education, in your own experiments, it sounds like you're coming to conclusions, which it sounds like I could definitely agree with numbers you have.
There are a lot of problems. There are a lot of problems which I came to know that they were not even solvable before we had digitizations. So they were not solvable from the manual processes. So when I read more about these, how were they solved? One, those problems were solved using machine or using the automation or putting those mathematics on the machines using computing. There were some remarkable piece of discoveries. So one such problem is something called thumbprint of God. There is a complete documentary. One of the IBM scientists, he basically was looking into solving one of the problems, which was how to map the area of coastal lines in order to identify some solution for, I think, something to do with identifying the areas and how much of volumes were to be used for some kind of problems. And he came across putting up one of the most simplest replicatable mathematical equation, which allow them to understand how simple equations, when they are replicated with only one variable, how the complexity is basically created. So how a simple thing can actually contribute to the complexity. So these are some very remarkable things which were discovered. So that is what allowed me to understand how the information behaves in a certain manner with only very smallest piece of changes. So my view is there is more maths which is going to be discovered eventually, now that we have moved into a realm where a large piece of information can be stored into a very small area.
So I think this is a great discussion. On the interest of time, we should probably move on to the last topic.
Yeah.
Yeah,
For sure. Miki, let's talk about this. It's very interesting. I want to talk about this more. Come to AI Makerspace, and then we can
I am going to
hear a little bit more. Thank you for your input. Lastly, we do only have 12 minutes left. Let's try to be a little bit quick about this, but it's the ethics of AI-generated scientific knowledge. And by AI-generated scientific knowledge in this specific case, I mean how much AI was used in order to create or help create, generate scientific knowledge, not necessarily just putting up a bunch of numbers in and getting something out. I think we're all getting something relatively positive out of AI existing. I definitely am using a lot of ChatGPT, but every single time I do get onto ChatGPT, I do have to remind myself, well, a lot of this was trained on data that was not necessarily ethically sourced. And I wanted to end today's discussion with raising a little bit of thought on how AI gained traction to the day, and I wanted to see what your point of view on the ethics of AI is going forward in the realm of open science. So I'm not going to restrict it to Carlos and Enrique. Anyone can really say anything if they have something to say, but otherwise, Carlos and Enrique, do you have thoughts on this specific topic?
Yes, a little bit. For example, in our scientific practice, we need to be transparent. So if we are using large language models to write a section or to write a guideline, we have to be ethical and claim, well, this is LLM generated and we're using specific model. But the models keep changing every week or every day. So that's not reproducible. And also when we are using large language models to write a paper, scientific paper, remember that the authors are the ones who are accountable for all the content of the paper, not the large language models or AI. And also, it's a matter of fairness because large language models are biased. They have been using only specific part of knowledge and not including specific marginalized sections of the population. So we have to be aware of that and aware of how the large language models have been trained.
I like what you said there when you mentioned you're working on a paper, you need to be specific about what models I have used, what models what was used of this model in order to make this paper, publish this paper. And I think that is something that we may need to normalize going forward in the future. Nowadays, we can summarize things with ChatGPT, but going forward, I think if we do want to use AI, we will need to be explicit regarding I generated this information using this model. And I think that is going to tackle a little bit the topic that Enrique was talking about earlier, which is reproducibility and how difficult it is to tackle reproducibility and AI, because not every answer is going to be the same. And it's actually more difficult to get the same answer than getting an answer that is similar, but a little bit different.
Yeah, reminds me of the problem of accountability. We have
Okay,
seen all these
yep.
autonomous vehicles running around the
Right.
cities. So what if there is an accident and some person dies?
Yeah.
Who is responsible? The company who build the car?
Yeah.
The software engineers, the AI program? Who is accountable for that person's death?
Yeah, it really feels like the Wild West. We are yet to make rules around this. And I think the United States and Europe, for example, they have different approaches on what is ethical about AI. As an Italian, I believe that for a moment, ChatGPT was actually illegal in Italy, because the Italian government was trying to safeguard the safety of Italian information, of the Italians' information. So we are very much at the beginning of a massive discussion that is yet to be had about how ethic AI is and how we can use it ethically. Enrique, oh, okay. Wait, Tanishk has a question. Yes, Tanishk.
Yeah. So, am I audible,
Yes.
Mikhail? Okay. From the discussion that's going on about the ethical, I was just on LinkedIn yesterday and I saw a post where DeepSeek, they were testing DeepSeek and they just asked a political question. And it was very clear to recognize that DeepSeek has a clear political bias. And it's actually very worrisome because if all of us right now, so many LLMs are coming around and we are using LLMs everywhere, all that bias and all that data on which the LLMs are being trained, they can get into our work, they can get into whatever we are producing, and then it can actually represent something which is very biased. So what I'm wondering here is to tackle all of this, as you said, that it's the whole ecosystem right now is very wild. We don't have standard systems around it. So is there any organization or any solution oriented approach at global level which is now going on and organizing things? Because right now I see it's like everywhere. Everyone is doing anything or something, and there's no solution oriented direction to all of these things.
So I don't think that there's currently any organization with oversight for these issues. I agree with you, it's important. And I'm not sure, like, there's no simple solution to this. I think that right now, AI has become there are a lot of commercial and political interests around it, such that there are going to be multiple efforts to rein it in towards the goals of each individual organization or nation that wants to use it. So I think that there's going to be some turmoil, but eventually, in probably in a few years, when the technology matures enough, there might be some sort of committee or organization or government entity that will publish guidelines. But for now, I think that it's still the Wild West, and it's up to us to tackle those challenges in an ethical way.
Yes, yes, but we have to keep in mind what are large language models. Large language models are just models of word form distribution. So you have a bag of words, you make a probability distribution, and that distribution has been extracted from some text where the models were trained. But then by design, the large language models generate forms without substance. The synthetic output are not ideas, data, or information. And if you ask questions to DeepSeek and it's not capable of answering, it's not a database. You're just asking like a parrot, can you repeat me a phrase about this topic? And then it will generate that text. Right?
Yeah. I think in the interest of time, and this is obviously a topic that requires more than just 10 minutes to discuss, but I think I want to echo what Enrique has said, and thank you, Tanishq, for the question, where it comes down to, I'm trying to really know also what Carlos has said, these are just models that are created and rely on statistics. However, we aren't yet at a point where we know how we're going to handle it at a global stage. We do need to somebody needs to take accountability for something that happens. After all, Carlos, and the car problem is a great example of this. Who's going to go to jail? Is the manufacturer going to jail, the software engineer? At the end of the day, AI and LLMs are data or software that run on data. It is up to us to figure what to do with these tools, really. And I'm sorry I'm wrapping it up so quickly. If there is anything else that you guys want to add, Carlos or Enrique, please feel free to shout it out now. Otherwise, I do think that we are running towards the end of the hour. So, Enrique, Carlos, anything?
No, fine.
I think we covered most of it.
Everything.
It's
Okay.
an endless topic.
It's an endless topic. It really is. And the thing is, at the Data Science Institute, we talk about this almost every day. It's something that we do need to talk about between ourselves, about what's ethical, about what is the next big step for AI. How can we best introduce AI in in an ethical way here at the U of A? How can we educate people on what AI does? And that's why we have the various series in generative AI, classical machine learning, and now even FOSS AI. Next week, we're going to be switching topics around, and we're going to be talking about, okay, you want to do AI? Let's see what to do with dealing with compute. So we're going to talk a little bit about Jetstream 2. And the week after, we're going to dip our feet into actually labeling things and starting our own pipeline. So with that, I would like to thank you very much. There we go. Thank you all for being here today and joining the conversation. It's been a conversation where I learned a lot as well. And with that, thank you. Have a great week, and I hope to see you next week.
Thank
Goodbye.
you.
Oh, yeah, and thank you, Carlos, and thank you, Enrique.
Thank you.
I'll see you in 30 minutes. Okay, I'm gonna stop the share and stop the recording.